What if the future of robotics is not hard and metallic, but soft and flexible? Imagine a world where robots could squirm into the tiniest of spaces, handle the most delicate objects, and traverse terrains that were once deemed inaccessible. Welcome to the world of the Robotapillar, a groundbreaking creation that combines the simplicity of paper with the sophistication of cutting-edge technology. Crafted by a team of visionary researchers, the Robotapillar stands out from traditional robots with its exceptional flexibility and adaptability. At its core, this robot is composed of cylinder-shaped segments, each adorned with a unique pattern. These segments can operate independently or link together, forming a longer, more versatile chain. What truly sets the Robotapillar apart is its ability to flatten and then return to its original shape, a feat made possible by the innovative Kresling pattern. This pattern empowers the Robotapillar to twist, turn, and navigate in any direction, mirroring the natural movements of a caterpillar. At the heart of the Robotapillar's design lies its unique structure, which starkly contrasts with the traditional rigid frameworks of conventional robots. Crafted from a series of cylinder-shaped segments, each adorned with its own intricate pattern, the Robotapillar boasts an exceptional level of flexibility. This isn't just any pattern, it's the Kresling pattern, a design that allows these segments to flatten entirely and then spring back into shape. This capability enables the Robotapillar to twist, turn, and navigate through environments in a manner reminiscent of its biological counterpart, the caterpillar. The Kresling pattern, inspired by the natural folding process observed in certain plant structures, is the secret behind the Robotapillar's extraordinary mobility. This geometric design allows each segment to collapse and expand, enabling the robot to maneuver through complex environments with ease. Whether it's wriggling through narrow passages or curling around objects, the Robotapillar does so with a grace that belies its mechanical nature. Beyond its ability to explore and adapt, the Robotapillar is also capable of carrying objects and reaching into spaces where human hands or traditional robots cannot go. This makes it an invaluable tool for tasks ranging from intricate surgical assistance to challenging search and rescue operations. Researchers have enhanced its functionality by integrating a steering system that increases its range of motion and control. Additionally, at institutions like North Carolina State, advancements have been made in controlling the Robotapillar's movements through materials that expand or contract when heated, coupled with a stretchable heater crafted from silver wires. This technology allows for precise manipulation of the robot's form and trajectory. Despite its current limitations in speed, the future of the Robotapillar looks incredibly promising. Teams are diligently working to enhance its speed and versatility, experimenting with various shapes and patterns that could further revolutionize its capabilities. The potential applications are vast, from medical fields where it could handle organs during surgeries to space exploration where its ability to adapt could be crucial. What truly sets the Robotapillar apart is its ability to perform in scenarios where traditional robots might falter. Thanks to its soft, pliable body, it can squeeze through narrow passages, handle fragile objects with care, and move with a precision that mimics the natural world. Imagine a robot that can navigate the cramped and twisting passages of a collapsed building for search and rescue, or delicately maneuver through the human body during complex medical procedures. The technology underpinning the Robotapillar is equally fascinating. Researchers have integrated a sophisticated steering system that enhances its adaptability, allowing for even more precise movements. The use of materials that expand and contract when heated, combined with a stretchable heater crafted from silver wires, provides the Robotapillar with the ability to fold and bend with meticulous control. This level of precision points to a future where the Robotapillar could be an indispensable tool in surgeries, delicately handling organs or navigating through minuscule incisions with ease. However, the journey of the Robotapillar is just beginning. Although currently it moves at a slower pace, ongoing experiments are focused on enhancing its speed and agility. Researchers are tirelessly testing different shapes and patterns to find the optimal configuration that could further revolutionize its capabilities. The Robotapillar represents a significant leap forward in the field of robotics. Its blend of origami-inspired design and cutting-edge technology allows it to perform tasks that were once deemed impossible for machines. As this technology continues to evolve, the potential applications extend across various industries, from medicine to space exploration, opening up a world of possibilities where the Robotapillar could indeed turn the impossible into the achievable. This tiny, adaptable machine is not just a robot, it's a glimpse into the future of innovation inspired by the natural world around us. The Robotapillar is a cutting-edge soft robot that's inspired by the art of origami. It's designed to be highly flexible and adaptable, which sets it apart from traditional robots that are usually rigid and limited in their movements. Medical field. Right now, the Robotapillar's flexibility and delicate handling make it ideal for medical applications. It can navigate through small incisions, which is a game changer for minimally invasive surgeries. This could potentially reduce recovery times and improve surgical outcomes. Search and rescue. Its ability to collapse and expand allows it to enter and move through tight spaces that are inaccessible to humans or rigid robots, making it perfect for search and rescue operations in collapsed buildings or other confined environments. Aerospace and construction. The Robotapillar could be used in aerospace engineering for tasks that require precision and adaptability in confined spaces. In construction, its ability to carry and manipulate materials could be harnessed in areas where human access is limited or dangerous. Advanced surgeries. In the future, it might be used to perform complex tasks during surgeries, such as grasping and positioning organs or navigating to specific areas within the human body. Modular robotics. The concept of modular robotics is also being explored. Each segment of the Robotapillar can function independently or connect with others to form various shapes and lengths. This modularity means robots could be customized on the fly for different tasks or repair themselves by replacing damaged segments. Cresseling pattern. The cresseling pattern is an origami technique that allows the robot to twist and expand, enabling it to crawl and change direction. This is the key to its versatility. Material science. The use of materials that react to heat by expanding or contracting, combined with silver nanowire heaters, allows precise control over the robot's movements. This technology could be further developed to create robots that respond to other stimuli, such as light or electricity, opening up even more possibilities. In essence, the Robotapillar represents a leap forward in robotics, combining the simplicity of origami with advanced materials and control mechanisms to create a robot that can adapt to a wide range of environments and tasks. Its current and potential uses span from the operating room to outer space, showcasing the vast possibilities of soft robotics.